So we now move to our units about acids. So let's get started straight away. Which ion in solution are acids a source of? Acids are a source of hydrogen ions. Essential, you know that. Hydrogen ions. So if a substance has a lot of hydrogen ions in solution, then it will have a high pH. So essentially the hydrogen ion concentration is a measure of how strong or weak an acid is. Has hydrogen gained or lost electrons in forming the hydrogen ion? Well, let's have a think about that. Hydrogen's got an atomic number of 1, which means in the nucleus it has 1 proton and 1 electron. Okay, so if it's going to become the hydrogen positive, the hydrogen ion, that electron there is going to have to depart, it's going to have to go, leaving that positive charge on its own. So the hydrogen ion has lost, the hydrogen atom has lost an electron to become a hydrogen ion. That's just a revision from the first module on bonding. Which ion in solution are alkalis a source of? The answer is hydroxide ions. The OH minus ion is the hydroxide ion. Okay, so far let's box that off and let's box that off because it's essential you know those two things. Hydrogen ions, a high hydrogen ion concentration makes something strongly acidic. A high hydroxide ion concentration makes something strongly alkaline. This box here, you don't need to revise this. Don't need to revise. This is just to get you thinking back to that unit on bonding we did right at the start. So don't revise. This was just here for a bit of fun, really. Can we draw a dot and cross picture of the hydroxide ion? Okay, the OH minus ion. Draw the outer electrons only. So oxygen here has got 2 electrons on the first shell. We're not going to draw the first shell, we're just going to draw the outer shell, and 6 electrons on the second shell. Okay, so that's 1, 2, 3, 4, 5, 6. It's bonding to a hydrogen. So oxygen and hydrogen are non-metals, so they bond covalently. A covalent bond is a shared pair of electrons. Hydrogen's got 1 electron, so we're going to put 1 electron in that overlap there. So that keeps that that hydrogen happy. It's got 2 electrons on the outer shell. The oxygen here, 1, 2, 3, 4, 5, 6, 7. This is not happy, so we're going to need to bring an electron in from somewhere else. Okay, E minus transfer. Okay, and let's put that one there. Okay, so that one's coming from somewhere else. So this has now gained an electron. The E minus has come here. This makes the whole thing negatively charged. So there is our hydroxide ion. Okay, I say that's not doesn't need to be revised for GCSE, and if you don't quite understand that, don't panic on it. Okay, it was just there, as I said, for a little bit of fun and just so we can revise in class really a bit about bonding. This, however, is essential. What is the name of the reaction between an acid and a base? The answer is neutralization. Okay, acids neutralize bases, or alkali is a type of base. Okay, so next page. All right. What do you think is made when the ions from acids and alkalis react? Write an ionic equation to show this. All right, so the ions from an acid is a hydrogen ion, and the ion from an alkali is a hydroxide ion. So we've got 2 hydrogens and an oxygen. 2 hydrogens and an oxygen. Looks all feel like water to me. Water. Okay, so in what that says, in a neutralization reaction, acid reacts with alkali. One of the products is always going to be water. So an ionic equation now, the hydrogen ion reacts with the hydroxide ion to make water, and that is an ionic equation for neutralization. Okay, so we can measure acidity and alkalinity on the pH scale, and we need to know about that. So numbers 1 to 6 on the pH scale are acid. Numbers 8 to 14 on the pH scale are alkali. This one in the middle here, number 7, is neutral. Water is neutral, for example. Okay, numbers 1 and 2 are strong acids. Okay, 3, 4, medium acids. 5, 6, weak acids. 8 and 9 are weak alkalis. And 13 and 14 are strong alkalis. Colour. So this is with universal indicator. This is adding universal indicator. Okay, acids themselves aren't the colour without universal indicator. When we add universal indicator, we get a certain colour and we can identify the pH. So to do this, I've stolen my daughter's pencil crayons. So let's put some of these in. So if we add universal indicator, to strong acids, and it goes dark red. We've got pH 1, light reds. So I'm cheating here. I'm using the same pencil correction, just doing it a bit lighter. That would be light red for a 2. We'd have a pink for a 3. I don't think you need to learn all of these. Just the trends really. We have an orange for a 4. So there we go. We have a dark yellow for a 5. So press quite hard there. And a light yellow for a 6. There we go. There is a acidic ones. Neutral. pH is neutral is green. Definitely need to know neutral is green. In the same way, we definitely need to know dark red is strong acid. After that, we'd have a dark green for a very lightly alkaline, very weak alkali. Now, a bit of a turquoise, a bit of a blue-green here. A bit of a blue-green turquoise for number 9. Let's have a light blue now for number 10. We start to move to blues after that. Sort of a fairly medium blue for number 11. Again, I'm cheating. I'm just using the same colour, but pressing a bit harder. And then a dark blue for number 12 again. Bit cheating that, but you get the idea. And then 13 is a light purple. And then 14 is a oh. And then 14 is a dark purple. So I don't think we need to learn all those. Just the basics really. Red for strong acid, green for neutral, and dark purple for strongly alkaline. Right, what is the link between hydrogen ion concentration and pH? Let's do this box next. So the link is the higher the concentration of hydrogen ions, the lower the pH. Okay, so the higher the concentration, the more hydrogen ions we have in solution, the lower the pH is. Now there's a second trend as well. There's a second link we need to know about. As the hydrogen ion concentration increases by a factor of 10, the pH decreases by 1. Okay, so it's not a straightforward scale. Oh, it is a straightforward scale. It's not as you would expect. So we have to increase the hydrogen ion concentration 10 times to decrease the pH by 1. And this is what we've got in this last box here. So we've got a hydrogen ion concentration of 0.1 mole per decimeter cubed. To get the pH to rise to 2, we have to decrease the hydrogen ion concentration. It has to get weaker by 10 times. So to go to 3, we have to dilute this 10 times again. So it's going to be 0.001. Okay, so you can see there's a huge difference in concentration between that. It's 100 times difference in concentration between 1 and 3, and that only changes the pH scale by 2. So that's 1 times 10 to the minus 3 in standard form. Okay, so to get to 4, it'd have to be 1,000 times weaker than a pH of 1. So we'd have to dilute it by 10 to get to 2, 10 to get to 3, and 10 again to get to 4. 10 times 10 times 10 is 1,000. So that's going to be 1 times 10 to the minus 4 and 0.0001. Okay, and you can have a go at filling those in now. The boxes are like this, so you can write sideways down. Let's just do the next one just to make sure it's clear. I'm going to turn it around for a second. So this is going to be 1 times 10 to the minus 5, so that's going to be 0.00001. Every time we decrease the concentration by a factor of 10, pH rises by 1. Next bit, complete and colour the table to show what effect acids and alkalis have on the following indicators. So up until now, we've probably just concentrated on universal indicator, but we need to know about these 3 other indicators as well. First off, litmus in acid is red, so you can colour that in on your own, and in alkali it is blue. Methyl orange in acid is red, and in alkali is yellow. Phenolphthalein in acid is colourless, and in alkalis is pink. Okay, very important we learn those. When a base reacts with an acid, what is always produced? Okay, answer. There's 2 answers here. Salt. A salt is produced. Salt's a neutral. And water. So acid plus base makes salt plus water. And we've now got a tiny bit to finish off here. Write a common equation for the reaction of an acid plus base. Okay, absolutely essential we commit this to memory. Acid plus base makes salt plus water. Okay, so let's just square that off and write essential on the top of it. So, and remind ourselves, acids are a source of hydrogen ions. Let's put that down there. Bases are a source, or alkalis are a source of hydroxide ions, and water is H2O. So that, there's our ionic equation for that reaction as well. What type of reaction is this? Neutralization. What is an alkali? An alkali is a soluble base, a base that dissolves in water. A soluble base, and it's a source of hydroxide ions. Hydroxide ions. OH minus. So if you know alkalis are hydroxide ions, contain hydroxide ions, that's great.